Hello guys, how you doing today? My name's Anton Alexander. I'll be giving you a workshop today about scaling your AI apps to production with Kubernetes and GPU. So today we'll be talking about using Docker, Kubernetes, and NVIDIA GPUs to scale your applications on cloud infrastructure or local infrastructure. If you're building generative AI applications that are actually using GPUs, you need these applications to be able to scale, and you need to be able to be cost effective, right? So this is the topic of today's workshop. The workshop agenda today will be introducing you to Kubernetes and Docker. We'll be talking about GPU integration into Docker. We'll be talking about Kubernetes for GPU deployments, and also be talking about automated builds and CI/CD, constant integration and constant development. As you develop your application, as you write your code, how do you push your code to a production environment? Then we'll talk about deploying your application in 3 environments and the overall architecture discussion. Okay, so like I said, we can go to the next slide. All right, so today we'll be talking about Kubernetes. And what is Kubernetes? Kubernetes is an orchestration technology developed by Google. 85% of the internet runs on Kubernetes. NVIDIA, who develops GPUs, their AI enterprise GPU hardware and software runs on Kubernetes. So if you deploy NVIDIA H100s, V100s, A100s, like ChatGPT was trained on over 1,024 V100s. It was deployed and trained using Kubernetes to control the infrastructure, right? So Kubernetes enables API-driven software and distribution, making automation, self-healing, and scaling your application basically automatic, right? What is Kubernetes a solution for? Kubernetes basically solves the challenge of autonomously scaling your application horizontally and vertically. If you need more CPU resources, Kubernetes will talk to your server, talk to your compute infrastructure, and request more CPU, memory, and GPU. But if your application doesn't have that many users, it will scale down your infrastructure needs, right? This is one of the good things about Kubernetes. Let's go to the next style, right? Production Kubernetes is basically how you handle your production traffic for your applications. So as your applications scale, you have load balancers, which Kubernetes deploys for ingress and egress, right? And these load balancers handle the traffic that's coming into the application. As you have more users, Kubernetes will manage and scale and redirect traffic. The core components of Kubernetes. Kubernetes has several components, right? And we'll talk about them. The functionality overview is basically scheduling workload, exposing a declarative API, which means that you can structure and deploy your infrastructure as code, right? And it offers, check. Hello, yeah, and it offers an API and a command line interface for interacting with your infrastructure. Check. We'll continue for the Twitch guys, right? For all the people on Twitch, basically the key capabilities for Kubernetes is thank you, sorry guys. So the key capabilities of Kubernetes is scheduling workloads across hosts, basically making sure that your workload is up, it's running, it's available. Another capability of Kubernetes is declarative API system interaction. You can talk to Kubernetes and send commands to like, hey man, I need more computer resources. Hey, I need to deploy another endpoint or change my IP address. This can be done in the declarative API, right? Kubernetes also has a command line interface, which you can talk to Kubernetes directly from the command line. You can ask it questions like, hey, tell me the status of all the pods in my deployment, or tell me the health of my infrastructure. And basically it has basic routing capabilities, right? Let's go to the next slide. The Kubernetes cluster overview. What are the parts of Kubernetes, right? So this API is basically the central hub. It manages the communication between the different components in Kubernetes, right? So let's say I have an application. I have a React application, or I have a different app, and I have a database, a SQL database, and I have a Redis. How do they talk? Well, I define that through my API, right? Kubelet is basically your on-host agent. Kubernetes, it provides reports. It gives you your node statuses. So let's say I have a React application. I'm a developer. I have basically a generative AI application, right? I have a React front end. I basically need to manage my GPU. Let's say my Gen AI application is running and I have a lot of users and I need to queue these users, or I need to spin up more resources for my Gen AI. Let's say I have a speech recognition or a large language model running, right? I have my front end. A lot of users are coming. I need to scale up. Well, the kubelet handles that. And the other thing is the control manager. Basically, this is a core application. It basically, it allows you to replicate your deployments. So let's say I have a pod, like I have a React application, or I have a database. I have lots of users coming in. I need to copy this database so I can manage and handle all my users. That's what that handles. Then I have the scheduler, which of course schedules basically things on roles and permissions. And I have a proxy. Proxies are just virtual IP addresses. So if I need to create virtual IP addresses within my cluster for routing, like reverse proxies, right? So let's say I have let's say in my cluster, I have a React application. It has an endpoint for doing several things. Then I have another endpoint for basically my large language model or my generative AI. I have another endpoint for my database. I have another endpoint for these different things. These, inside the clusters, as you know, in Docker, these will have different IP addresses. But with a reverse proxy, what I would do, as I expose my app to the internet, I can't have multiple IP addresses, right? So what I would do, I will flatten the IPs into one IP, and in my cluster, I have different IPs assigned to them, right? Like a Docker container. And what it would do to take the IP and the port, basically, and map it to the correct IP and port within my container. Okay, so next step. This is the overview. You guys can't see this, but my Twitch people, you can see it. So this is the overall architecture of how Kubernetes kind of works. You have nodes within your cluster, and you have a control plane. Your control plane contains all those management components that I mentioned. Then, as your declarative YAML file, or you make command line calls to Kubernetes, it creates nodes within your infrastructure so that you can deploy your application, basically, right? And like I said, 85% of the internet runs on Kubernetes. It's developed by Google. Google initially published a paper named Board. And for your information, at OpenAI, the guys that train ChatGPT, they just started training ChatGPT. And how are they training it? Well, they're using distributed computational platforms such as Ray, and they're running it on top of Kubernetes. So ChatGPT is trained by using Kubernetes, by the way, right? So let's go to our next slide. Benefits of using Kubernetes for AI. Why would I, as a developer, want to use Kubernetes for AI? Well, basically, NVIDIA, which makes the GPUs that run your ChatGPT, for all you guys using ChatGPT, guess how it's being deployed and served to you? It's being deployed using Kubernetes, right? And what is Kubernetes doing? Kubernetes is automating the life cycle of the application. It's managing the containers that host the application or the API endpoint, right? It basically allows you to scale your application. So GPUs are very demanding resources. If I'm using one GPU, it's going to cost much less than if I'm using 10 GPUs. And I don't want to sit there and monitor how many people are using my application. I want to automate this process, right? So I don't want to sit in front of Google Analysis and look at, oh, I have 100 people, oh, I have 1,000 people. Let me scale up and scale down my GPUs on Google. No, we use Kubernetes to manage this. It will scale the pods that are using GPUs by user demand. And these are one of the things. And it offers security capabilities, not exposing your internal APIs to the public, okay? And it has fault tolerance and self-healing. Let's say a pod goes down, or a specific component of your application goes down. Then Kubernetes will redeploy it automatically. So that's one of the benefits of using Kubernetes, okay? So let's go to the next slide. What's Docker? Docker is a key component, right? Docker is basically, it's an open source platform for shipping, running applications in separate containers on infrastructure. What Docker does is allow you to package your application, right? Years ago, in the early 90s, maybe some of you were born in the 90s or not even born yet, developers ran their application on mainframes, right? So in these mainframes, basically, they would have to deploy the entire application, the database, the app, the Nginx, everything, right? Later on came VMware. VMware changed the game. So you could deploy a VM, have multiple VMs running on a computer, and deploy your entire application in a VM, right? So this allowed us to kind of like separate or segregate our compute resources into virtual machines, VMs, right? But then Docker came into play, right? So Docker, what Docker does is that it takes a specific part of the operating system, and you can select the operating system. Hey, I need Windows, hey, I need Linux or whatever. And you can say, I need a Python container, or I need a container that has CUDA. You just take the part of the application that you need. If you need Python, you get a Python Docker container. If you need Nginx, if you need a SQL database, ready to go, ready to deploy, you pull in your Docker container, it's readily available to you. And what this introduced to the market is microservice architecture. Microservice architecture allows us to have microservices that are small components of our application that we can manage and scale. Before, as I mentioned, when they had VMs, we'd have to have a VM, it would have Nginx, it would have our database, all the components of our application running on a VM. Let's say, for example, the database was using all the compute resources. I would have to make another copy of the VM, right? But with Kubernetes and Docker, what it allows me to do is that Docker, I can just have my SQL database running. If my SQL database has a lot of commands, a lot of queries to it, I can just scale up that one part of the microservice. I don't have to make another copy of my VM, okay? So Docker allows you to basically take a specific, Docker allows you to take a specific part of your application and just focus on that development. Then I can connect my database to my React application, to my Redis, to my Kafka, and all to my HTML, all the different components of my application as microservices, right? So that's what Docker allows me to do. It basically, and the applications, those segments, they live in a part called a container, and they can all scale individually. So I can scale my database, scale my React application, scale my Nginx and everything. Next slide. All right, AI and Docker. What does AI and Docker do? I think that for AI, Docker is a game changer. Docker is like the best thing an AI developer can have at their fingertips. What does Docker allow me to do? Much of you guys, I don't know, you might use automated AI tools, but when you start doing real AI, you're gonna have to install NVIDIA drivers, you're gonna have to install PyTorch version, TensorFlow versions, different version of AI frameworks. The most popular in the world is PyTorch and TensorFlow, right? As I build my AI applications, basically, it's very complex installing AI drivers, CUDA, NVIDIA drivers, CUDA DLL, right? So TensorFlow, PyTorch, ChatGPT, your favorite generative AI, image software, all these are built on top of CUDA. CUDA is a language from NVIDIA that they created for accelerated computing. NVIDIA GPUs, the language that they speak is CUDA. That is the language of GPU. Managing these things can be very complex, but by using Docker, we can pull in the containers with all the pre-installed software, all the drivers, all the CUDA drivers, all the CUDA DLL drivers already pre-installed. So as a developer, all I have to do is just develop, basically. I don't have to focus in managing hardware, managing drivers, right? So that's what it does. Also for CI/CD. What is CI/CD? CI/CD stands for constant integration, constant development. As I push new updates to my application, I want these applications to be updated in my container registry, right? That's where I store my Docker containers. So as I code and I make changes, I basically push these changes to the container, and then the container gets uploaded to a registry. If that registry in my build chain detects I push the new containers, it will pull this container and deploy it on the internet. So if I'm in my production environment and I make a change to my GitHub, GitHub will automatically trigger a build of my new Kubernetes container, and it would take this container and push it to production on my website. So I enjoy, one, my application is containerized, right? Secondly, my application is managed by Kubernetes. If the new build I push to the internet fails, Kubernetes will try to heal it or even go back to my last working container. So these are the benefits. Let's go to the next slide, right? So right here, you'll see how the containers work. You have your infrastructure, typically your NVIDIA DGX, or you're in your cloud. You're running on your cloud instance, right? On top of that, you have the host OS, typically Linux we use for machine learning. On top of that, you have your Docker container, your Docker engine, and your Docker kubelet will be running. And on top of that, you'd have your applications, right? So this is the typical structure of Kubernetes and Docker, and this is how NVIDIA has recommended users to run their applications. Next slide. So basics of containerization. So how does containerization work, right? Containers are encapsulated software that allows a user to basically develop inside the container. You would go to something called Docker Hub. NVIDIA has something called NVIDIA Container Registry, where all their latest containers of the AI software is available. You pull the containers down to your laptop or to your development environment, and then you would do your development in your container, right? Containers basically promote resilient sharing and efficient management of dependencies. Because as a developer, I don't have to pip install all my libraries, pip install PyTorch, pip install this. I have all my version dependencies, and my dependencies are maintained in my container in the build script, which is called a Docker file. So let's say I'm using PyTorch version blah. I'm using SQL version blah. I'm using Redis version blah. So all my versions are maintained in my Docker container. And this, across my entire organization, from testing to production, the versioning is maintained. And basically, this allows me to basically maintain my CI/CD and maintain my version and my software coherence across, if I'm developing on my laptop, if I'm a data center, or if I'm in the cloud or local. All of my production environment stays the same. Next slide. This is just an image of how NVIDIA integrates GPU with Docker. So NVIDIA runs basically on Docker. So if I buy NVIDIA is the heart of generative AI. That's how most generative AI platforms are running on NVIDIA. NVIDIA recommends that you run the NVIDIA GPU in Docker containers, and basically you buy your NVIDIA GPU server, you install your CUDA drivers, you install Docker, and on top of that, you basically pull in NVIDIA containers and you develop your application in NVIDIA containers. And this is how more sophisticated production grade generative or just AI in general is deployed, right? So if you're really serious about AI and you're really deploying AI in production, this is how it's recommended by NVIDIA to deploy your AI. Next slide. So making GPU work in Docker. So this part was actually like a live part that I do, and I show you guys how to install your GPU drivers. So basically, if you have a GPU, you basically run this script, and that's it. Your NVIDIA drivers are installed. So basically, you add the NVIDIA container toolkit, and you're ready to go. You're ready to deploy applications. And then you can pull in your Docker containers, and you can start developing. So that's the gist. So basically, this is kind of like the end. This was like a live demo part of my presentation. Yo, Hamza. Yeah, so basically this is like the end. This was a live demo. I was showing you how to pull an NVIDIA Docker in and basically install TensorFlow in the container and run like a tensor code. No. Like, for all the Twitch people, how many people are on Twitch? Yo, what's up, Twitch?
Don't know even.
Yeah, it's a lot. Yeah, I hope, right? What up, Twitch? So yeah, these are examples from my Twitch people. Basically, you can see this is how to check that your TensorFlow GPUs are running. You can go on. Yeah. So this is an example of a Kubernetes infrastructure running on NVIDIA GPUs with Docker containers. You can go to the next slide. This is a Kubernetes GPU deployment overview. So this is how we deploy Kubernetes on AWS, GCP, Azure, or NVIDIA-based GPUs. You have your NVIDIA GPU, you have Docker, you have your GPU application, and you have Kubernetes sitting on top of it. So that's the gist, right? So NVIDIA actually actively contributes to making Kubernetes GPU aware. So NVIDIA is actively involved inside Kubernetes, basically. Key features and solution, NVIDIA enables GPU support. They integrate GPU monitoring into the NVIDIA stack Prometheus and Grafana, and officially supported by DGX Compute. So when you buy an NVIDIA compute unit, they officially support Kubernetes. It's built in. The operating system is actually, the DGX OS is deployed on Docker. FYI, so like, this is kind of like really important to know if you're like trying to scale your applications to production, because NVIDIA is using the Docker and Kubernetes infrastructure. All right, so how NVIDIA GPUs support for Kubernetes. NVIDIA basically has something called Triton Inference Server and Kubernetes, right? So if I develop a model, I build a model. Let's say I build a computer vision model, an ASR model, a generative AI model. Like I build a real model. I'm not like fine tuning on the internet and using APIs. Why I say a real model? Because let's say I'm doing ASR. If you go right now, right, and you go on Google pricing or you go on AWS, let's say that you want to build an application that records meetings, transcribes meetings, and sends them to the users. Or you want to build a Gen AI application that uses OpenAI ChatGPT. Let's say you're a company and you're really trying to make money. You're trying to get to maybe 10,000 users. It's a small amount. And you want 10,000 users continuously, right? If you calculate how many tokens per second or how many minutes of audio transcription that will be, well, it's a simple calculation. There's 720 hours for one person in a month. You multiply that by 60, right? That's the amount of minutes in a month. And let's say ASR costs you 2 cents. And then multiply that by 10,000. That's how much it will cost you just to transcribe audio. You're talking about millions of dollars, right? Just to support that. But if you can deploy your own GPU infrastructure, you'll reduce your cost by 15x. Literally by 15x. So if I'm a startup, either I'm gonna burn my money using cloud services, or I can basically smarten up, use Kubernetes, deploy my application using Triton Inference Server, and reduce my computational cost by 15x, right? So Kubernetes GPU deployment, what's the main objective of this? It's basically combining NVIDIA GPUs with Kubernetes for cost-effective task execution. If you have the skills and the knowledge to deploy your application on Kubernetes using GPUs, using models that you've created, you could save massive amounts of money. And you actually own and have actual AI products, right? We've seen that whole everybody who was doing ChatGPT applications, raising money in Silicon Valley, all those companies got wiped out. Who remained was the company that actually built meaningful applications using open source technology. Let's go. Basically, this was active part for setting up and installing Kubernetes. This is for another workshop I did for Gaia. But I appreciate your time and patience, guys. It was a pleasure being here. It's an honor to be here and present to you guys. Thank you, guys. I appreciate it. Have a wonderful day. Thank you. Thank you, guys. Huh?
Very nice.
Oh, thank you, brother.